Welcome to the 8th episode of Under the Hood. So when we started this series, the very first episode was about AI, where back then we talked about a little bit about prompt engineering and kind of scratched the surface on what this LLM was about. And then we thought that was about time to do another episode on AI, and we'll look into some slightly different topics this time. So with me today I have Klaus. Hi, Klaus.
Hello.
Klaus, you've been working with data science and AI for quite some years now. So please tell us a little bit, introduce yourself and tell us a little bit about yourself.
Sure. Yeah, so my name is Klaus Marius Hansen. I work as a principal engineer on Business Central, all things AI. So I was thinking about it and looking back, I started working on AI and machine learning in 2005. So it's 20 years ago.
So before LLM was a thing?
Yeah, before LLM was a thing. So we were building sensors for cars to record road conditions, and then we used machine learning models to detect whether the road was icy or not, and then warn the driver.
Predictions?
Yes.
Or, yeah.
So
that was the traditional...
That was the traditional machine learning. And that's also what I did when I joined Business Central back in the days, or NAV. So I was part of building the first machine learning and AI features. So the forecasting feature in Business Central, the classification, the regression, and the image analysis things.
So these are the early AI features. So it's fair to say you were the one who introduced AI in Business Central.
Yeah, guilty.
Yeah. All right. So you also worked on other products?
I did.
Other than which are not Business Central?
Yes. So after Business Central, I've worked on Power BI for a longer period. So this was back in the days before there was any AI in Power BI. So some of the things we did was to do automated machine learning. So this idea that you come with your business data. You want to predict something in your business data, but you don't necessarily have the skills, or you don't have a data scientist to massage your data and do prediction. So we did automated that for people. We also built some of the we built the first AI visuals, as they're called in Power BI. So if you ever use Power BI and use key influencers, decomposition, tree analysis, anomaly detection, things like that, that's something I built at least the back end of. So the idea is that you put all your data on a report, and then you can add these visuals. For example, key influencers, you can tell, okay, what is the thing that most influences your sale in Germany or something like that. Yeah. So we do run these machine learning models in the background.
Or find an anomaly in the list of...
Yeah, find an anomaly in your sales or in your, whatever you can do in Power BI.
And these features are still available in Power BI?
Yes, they're still available and widely used. And then interestingly, one of the last ones I built was called Smart Narrative. So this idea of you put a lot of stuff on your Power BI dashboard, and now you want a textual explanation of what's there, right? So a summary. And that sounds very much like large language model and generative AI, but this was before generative AI.
So that was not using...
There was no GPT. There was right around the time of GPT-3, so we had to build all this kind of by hand.
Okay.
And that's one of the things that are much easier today with the LLMs.
All right.
Yeah.
Okay, cool. So we are going to talk today. We are going to talk a little bit about small language models, because everybody is a lot of people are familiar with large language models. Things like ChatGPT are built on large language models. Microsoft Copilot is built on large language models. But there's also this thing called small language model. So, Klaus, what's the difference between large language models and small language models?
Right. Yeah. So it's in the size of the models.
Obviously.
So that's the thing, and the size is measured in terms of parameters. So parameters would be often, or most parameters are weights of matrices that are used when these models predict. Right, you give some text, it's transformed into some numbers, and those numbers are run through a bunch of matrices, and now you get some other numbers that are transformed into text. And then these matrices have weights. And so if we go back to GPT-3, this is 4 years ago, that had 175 billion parameters. And so OpenAI doesn't disclose the number of parameters on the current models, but GPT-4 was probably an order of magnitude bigger, right? 10 times bigger, or 20.
Yeah, there's some estimates about
that. Yeah, and the thing is, so even these 175 billion parameters, that's a pretty large number. It requires a lot of memory and processing power to
So that's
to
why
run
they
a
call
model.
large language model.
Yeah,
that's where the large comes
yes.
in the picture.
So it requires multiple GPUs to run a model like that efficiently.
How many GPUs would you run is required for running, say, GPT-4?
I'm not sure if they disclose those numbers, but I think it's probably around 8 GPUs you need to run GPT-4 efficiently.
Yeah. And each GPU has like, I don't know, hundreds of CPUs or processors on it.
Yeah, and the GPU is very expensive, right? So we're talking thousands of dollars per month to have a GPU, essentially. So that's expensive, right? So then, so what can you do to get a smaller model that's also performs, right? And what the way that these models have typically been scaled is, you train on more data, you add more parameters and so on. So one technique you could do was just stop at fewer parameters, maybe use the same amount of data and so on. But and that gives some smaller models that don't really perform as well as say GPT-3 and GPT-3.5 and so on. So some of the things that have happened recently, and Microsoft is kind of at the forefront of that, is you try to make models better by training on better data. So large language models are typically trained, we don't really know, but they're typically trained on all information on the internet.
A very large number.
Yeah, good and bad, right?
Yeah.
So the insight that Microsoft researchers had was that you could train on, say, textbooks, very high quality data, and by doing that, you could you could create models that had much fewer parameters, but were equally or were as good as models that were 10 times as big.
So
right?
smaller model in terms of
parameters.
How many GPUs they need to run on.
Yeah.
So probably cheaper as well, right?
Yes, so they're cheaper, right? So Microsoft, for example, introduced this, we have done this series of PHI models. The first one was released a year and a half ago with 1-point-something billion parameters, and the most recent Phi-4 was released this December with, I think, 14 billion parameters. And that clearly outperforms something like GPT-3 and is on par with GPT-4 mini.
So for simple tasks like summarizing or asking simple questions, maybe it's not as good as reasoning as, for example, 401 is.
Yeah,
but for many simple tasks, it's probably good enough, right?
And things that have math in it, it's specifically trained on program generation, things like that. It doesn't have a lot of knowledge about the world, right? So if you ask it about, what's the largest country in Europe, it might not be able to answer, but GPT-4 would have that knowledge. But then these 14 billion, that's small enough that you can run it efficiently on a single GPU. So it means that it's...
So you can even run it at home, maybe on your...
You can definitely
on your graphic
run
card
it
or something?
At home. It will be slow, but you can run it on a normal graphics card, normal GPU.
Well, whereas the large language model is practically impossible. It is impossible to run it at home unless...
It's definitely impossible, unless you have 8 GPUs or something like that. Yeah. Yes.
All right.
Yeah.
So one of the things that we've been working on recently in Business Central on small language model is fine-tuning.
Yeah.
So what is fine-tuning? What is this about? You might have heard people talking about it. So what's it about? And why do we do fine-tuning? And what can be used for? And tell us a little bit about about it.
Yeah. So let me talk a bit about fine-tuning. So looking at this slide here, or this picture here, to the right or to the left, sorry, is shown what you normally do to train an LLM. So as I said, you take a whole bunch of training data, books, websites, and so on. Here's Wikipedia, for example, and then you do what is called pre-training. So you essentially train an LLM to be able to give in some text, produce another bunch of text, and before a model such as 5.4 or GPT-4 is released, OpenAI or Microsoft train the model to, for example, do chat, right? And that's not pre-training. That's called supervised fine-tuning.
Okay.
So what you do is to show or to train the model on a lot of examples of chats, right? You give it some chat input and some chat output.
Some conversations.
Some conversations, yeah. And then you train the model, so that is you change the weights such that it becomes better at producing chats. And then you have like an LLM, such as GPT-4, GPT-4 Mini.
But that's a very heavy process.
Yeah,
right?
that's a super heavy process. But we can do the same as OpenAI does on this pre-trained LLM, and we can also do it in a more efficient way. So there are techniques where you don't have to adjust all the weights of the LLM to kind of specialize the LLM. So what I'm showing here is this process of fine-tuning. So the idea is, again, you come with your own data, so that could be even data from Business Central. You show the model examples of, okay, given this input, here's what kind of output we want. And then you do fine-tuning and you get another LLM, a GPT-4 Mini that is fine-tuned and that you can use as similar to the other LLM. And what can that be used for, right? So one thing that it can be used for is to make an LLM better at a specialized task. So let's say that you wanted to classify invoices you got to Business Central to a specific chart of account that you had, right? That's not something that GPT-4 knows anything about, probably. So then you could give a lot of examples of invoices and postings to a given chart of account, and then fine-tune, and you would have a model that would be very good at that. So that's one thing, like specializing the LLM to do certain tasks that it wasn't very good at beforehand.
But just to be clear, if you want to do that, it's because maybe the first step is to try it out before fine-tuning, right?
Yes.
To figure out, as you say, you would do that only if you find out that the model is not doing a good job to start with.
Yeah.
Because that's kind of a fine-tuning is still requires some skills. It's kind of a involved process, right?
Yeah, absolutely. So it's always the case that first you start with a prompt, then you try prompt engineering, right? If you forget about that, you can see the first episode of this show,
exactly.
right?
We'll put some links in the description.
And if that's not satisfactory, then you can go fine-tune. So this specialization is one like scenario you might want to use fine-tuning. Another one would be cost saving. So say that you have a feature where GPT-4 works just fine, right? It's very good. It gives you high accuracy, does what you want, but it's just too expensive. Then you might take a smaller model, say GPT-4 Mini, and give it kind of the output from GPT-4 and try to get the GPT-4 Mini to behave as GPT-4 on your scenario. So that's also something that we are doing right now.
So is that what's called model distillation?
Yeah, that's called model distillation.
So you take a big model, and which performs for your particular application well.
Yes.
And you take the output of that, and then you give it to a smaller model and train the small model to do the same thing and be good at that as well.
Yeah.
So you can do it cheaper and faster.
Exactly. So you sometimes talk about a teacher and a student.
Okay.
So GPT-4 would be the teacher.
Okay.
It knows what to do, right? And the GPT-4 Mini would be the student that learns from the teacher. Yeah.
Okay. So how much money can one save on doing that? Which you talk about cost saving.
Yes. Yeah. So there is the difference in pricing of GPT-4, for example, and GPT-4 Mini is a factor 10, 15. So you, potentially there's a large saving there.
Yeah. So factor 10 in your
cost. And if you do something like even smaller model, there's even more to save.
So actually, you could, even without fine-tuning, if you find out that your feature or your prompt works well on small language model, without fine-tuning, maybe it's even a good idea to try that out.
Definitely.
So do we support that in Business Central? Can you use small language models?
Yes. So what you can used for fine tuning is Azure AI, right? So there is this. We have this product called Azure AI Foundry, in which you can fine tune OpenAI models, so GPT-4o, GPT-4 Mini, and so on. And once you fine tune those, you can deploy them also from Azure AI Foundry, and then you can consume them just like any other model, OpenAI model that you do in the AI toolkit in Business Central. So yes.
But even if you don't want to fine tune, but just want to use, let's say you want to, I don't know, you do some simple summary or some, very straightforward thing that works well on small language models, even not fine tune. You can also do that in Business Central, right?
Yeah, so you can deploy a smaller language model in Azure AI Foundry. Yeah. And I think you can also use them in AI Toolkit.
Yeah. All right.
Yeah.
All right. So let's shift gear a little bit and talk about testing.
Right.
So how do you test this? Because testing is also traditional testing. Everybody knows it. We all know about that. You write some code, you write some test code, and then you run it, and then if it pass or failed. But language models, small or large, are traditionally not deterministic. So meaning with the same prompt, same data, you might have variation in the answers. So how do we? So we built some test framework. You've been part of that effort as well on Business Central. Can you tell us a little bit about that? What's the best practice here? What are we doing to test these features?
Yeah. So absolutely. Yeah. So the tricky part about AI and machine learning and so on is this non-determinism. So what you typically do is you define some measure of goodness, accuracy is an example that you measure. And then you keep track of that. So, for example, for the sales order agent that we are releasing now, we have a measure of accuracy that is, given an email to the sales order agent, does it process the email correctly and create the right sales quote? If it does that, good. That's good. If it doesn't, then that's a failure. And then you essentially run a lot of these and calculate the total number of runs you did and the successes, and then you have an accuracy. So we do that, and the support we have for that is the AI test toolkit. So these are normal AL tests that run in this AI test toolkit, data-driven tests, where the input for the sales order agent are emails, and we run the agent, and then we check with normal AL,
the proper
checks.
Sales quote
is the proper expected sales quote generated. So now the tricky part there is then to get data for this thing. So where do we get all these emails from and so on? You need a relatively large data set. So you need hundreds of tests for a feature like that. And there we are doing data generation. So that's another thing that these LLMs are very good at, is to generate data. So concretely, what we have done for the sales order agent is to create what we call seed data. So examples of emails from customers, examples of items and so on, and use that as input to GPT-4o. And so told us to generate new data.
So basically, you have an email that we handcrafted, right? And some data, and we give it to the LLM and say, generate some emails that resemble this one.
Yes.
Maybe with different combination of data, things like that.
And I would say so. The best practice is generally to do this this AI development in a data-driven way. So start by establishing tests. Data-driven tests, and make sure then that you drive accuracy to whatever you
acceptable number
to a good number. Yeah.
So we can test. So if I understand correctly, we can test whether. So we get an email. That's basically the input. Right? You get an email from a customer, right? Asking for a quote, for example. And then we can check, as you say, with AL code that the proper quote is created. But in the sales order agent, if you're not familiar with it, it's a feature which is in preview. We actually we have the LLM generating a reply to the customer, like a mail, right?
Yep.
And where we attach the actual sales quote, right? So how do we verify that the email is actually, correct, that, it's not just some, gibberish, and that it actually really answer the customer properly?
Yes, that's a good point. So we have two types of tests, and both have to pass for a scenario to work. So one is these AL-based assertions where you check that the sales quotes were generated correctly, and then the other is checking an email in the sales order agent case. And given that it's natural language, the only way to do that is to get an LLM to do it. So we also have support in the AI Test Toolkit for using an LLM to test features, and we use that to check, okay, did it write the correct thing, was the tone correct, and so on and so forth. We also use the same strategy in other features. So we have marketing text as a Copilot feature. The output of that is a marketing text. So if we have to do automated tests on that, we can't write those in AL. Again, we have a prompt that we apply that scores the output with coherence, fluency, creativity.
Okay, so we have a prompt that says something like, here's the email I just generated. Does it have the proper tone? Does it relate to the quotes?
Yes.
Things like that.
Yes.
And so we do these checks and ask the LLM,
exactly.
And we get like a yes or no answer. Yeah, right. So a little bit back to, I want to get back a little bit to fine tuning on small language models, because now we're talking about the sales order agent, and recently you and I did a little bit of work around this and trying to do some COGS optimization and model distillation. So can you talk a little bit about that?
Yes.
Because there was several parts in it. There was both some some synthetic data generation, some fine tuning, some testing. And then I think you also have some results you can share.
Yeah, I have some preliminary results that are promising, and I can share those. Yeah, so when we talked about fine tuning, right, we said that you need training data, you need some data input output. So the question is, where do you get that for fine tuning something like the sales order agent? How do you get good data? And so the observation you can make is that, okay, we have test cases. So we have hundreds of test cases that run. And if these test cases pass, that's actually a good behavior of the agent. So what we do is, we look at all our test runs. We look at what the agent did in the test run. Did it behave properly? If it did, we use that for fine tuning. And specifically, the agents do multiple things. So for example, it checks the email when it comes in. It when the agent is running, it operates Business Central, clicking and navigating, filling out fields, and so on. Yeah. And there's some other things it does. But the bulk of what it does is these execute task steps, as we call them, where it operates Business Central. So what we did is to take the input to all of these steps and the output for the cases where the test succeeded. Yeah, so now we have a data set.
So this execute task is actually quite crucial, because that's the one that, so as you say, there is some checking the email and some preliminary things, but this is where actually we ask the LLM, so what to do next? Where should I click? Where you click? Which fields you fill out? And so that's a quite complex task, which probably couldn't be done by anything else than an LLM if it's not trained, right?
Agreed, yeah. It's the heart of the agent, so to speak, right? Or the brain,
yes,
you could say. Okay, and now, so I have some preliminary data here from our experiment. So what I'm showing to the left is, we have this data we generated. If we run GPT-4 again on that data, does it say the same thing as as in the test run, right? So let's say you have a step where the agent filled in a value. So there's some input. We asked GPT-4, what would you do now? If it says fill in this field with the same values, then it's correct.
Right.
So that's what's shown here. So for example, here on the left, we ran through 10 emails, and in approximately 85% of the cases, GPT-4 did the right thing. So that's 84% accuracy. And that translates to some accuracy when you run multiple steps, but in this case. So then what we did was to try to do the same thing on GPT-4 Mini, and that's really bad. It's really bad at that.
Now you can see the difference between.
Yeah, now
you can really see the difference between how
Yeah.
proficient large language models
Yeah.
are against small language models for certain
Yes.
relatively complex tasks.
Exactly. Yeah. So in the example here, if we look at this scenario to the left, GPT-4 Mini achieves around 30% accuracy. So that's quite a significant drop, and so it's useless.
So we couldn't use it.
No,
we couldn't replace.
We could definitely
that
couldn't
step
replace.
with a small language model.
No. So then what we did is we took this data set that we got from the tests, and then we fine-tuned GPT-4 Mini, and that's the thing here to the right. That shows that if we do that, we get more than 90% accuracy on these execute task steps, which is pretty good. And in this case, it's better than GPT-4. And
That's really good.
Yeah, that's good. That's great.
But there's a but, right?
Yeah.
Because
So these are preliminary
Right.
results.
Yeah.
So I think in order to fully, bake this and ship it, we need to train this GPT-4 Mini on more data than what we have in our test. So that's
there's this thing called overfitting. Right?
yeah. So we don't test on the same, we don't evaluate on the same test cases that we train or fine tune.
You're not supposed to do that.
We don't do that here either. But the thing is that it's the same, customers and items and so on.
So the data are the same.
The master data is the same.
So there's a risk that because we have these data,
exactly.
So it's we have toys and so the toys have certain names.
Yes.
And that's the items we have, and the customers have certain names.
Yeah.
So there's a risk that when we've been training with this data, then the small language model that get fine-tuned is very good at recognizing these names and these item names, meaning that if we put it out there to a different customer with totally different data, somebody who's selling, I don't know, coffee machines, different customer names, it might not perform as well.
Yeah. So now back to data generation, right? So in order to fine-tune a model that we could release, we would need to generate more varied data, emails, items, and so on, and train on that. But this is promising.
Okay. Right.
And so that's the kind of bad news. But the good thing is then cost of this, right? So I took that scenario that I just talked about and plotted in it here, showing that GPT-4 achieved around 85% accuracy, but it cost around 22 cents to run these 10 emails in this case. Whereas if you look at GPT-4 Mini, it's super cheap, like 1 cent, but super bad. But GPT-4 Mini, then the fine-tuned version, then hits kind of a sweet spot because it's a little bit more expensive than GPT-4 Mini. It's twice the cost for running a fine-tuned model, but it has the same accuracy as GPT-4.
It's about 10 times cheaper than.
Yeah, and it's still a factor 10 cheaper.
All right,
which is great.
Cool. So what advice would you give to our partners and developers around small language models and fine tuning? Is that something they should look into? What can they do? How do they get started with it?
Yeah. So as we talked about initially, right, the first thing to do is always prompt engineering, few shot prompting, chain of thought, and all those things. But I think the tooling is quite good in Azure AI Foundry. So if there is especially model distillation is relatively easy to do. So if there is a feature that uses GPT-4 that has high accuracy but is expensive, then that's and you have tests, of course. Then that's or data of usage and can say which are good predictions by GPT-4. Then certainly you could fine tune a GPT-4 Mini and have the cost savings.
Well, you might want to try GPT-4. Or some small language models before fine-tuning.
Yes, right? Yes. Prompt engineering on GPT-4.
Also on small language models might be good results.
That's the first step. Yeah.
So that would be also cost savings to start with.
Yes. So definitely looking at GPT-4 Mini is a good idea.
Or maybe the Phi models as well.
Yeah, Phi 4 and so on is also good. And then there's also, because there are fewer parameters, in the model, it's also much faster. So if you have a scenario where you need speed, then it's also a factor 10 or so faster.
So so from you send a prompt till you get the answer.
Yes, it's much faster.
All right. But again, is it fair to say that if you get into fine tuning, you need to pay attention to the data you're using? That's the crucial part, right?
Yeah.
And that's where the work is. The fine tuning itself is maybe not. As you said, there's some good tools in Azure AI, but generating the good data set can be maybe challenging.
Yeah, that's the challenge. Yeah, I would say for the OpenAI models, it's very simple to fine tune, good tooling, and you have to, have good data. You have to make sure that it's representative, that it's accurate. You have to make sure that you don't train on the same data that you test on. All those things that you have to avoid to overfit, so that it only works on what you train it on. Yeah.
All right. Thank you, Klaus. We could talk about this for hours. That's it's a very exciting subject. At least we think it is. So we hope you enjoyed this episode, and thank you for watching.
Thank you.